Question. Motor tanker Alabama will leave from Channel Islands St. Helier Port with her 5.7-meter draft in 25th of December during PM flood tide period. There is a drying height in front of the port with 0.5-meter charted height, and ship wants to have 1 meter under keel clearance. It will take 24 hours to reach her next port of call, Folly Inn. There is a shoal with 4.7-meter and bridge with 30.2-meter charted height. Master wants to have 1 meter clearance for the bridge. Height above keel is 36 meter. Find the ETA, ETD, and tidal current values for departure, C tidal diamond, and arrival, B tidal diamond times. To find the height of tide minimum value, we have to subtract what we have from what we need. So what we need to is equal to our draft plus under keel clearance. And what we have is equal to drying height. But drying height is a negative thing, so we take that value negative. So if we do the math shown on the screen, we'll get 7.2 meters. We'll save this value for later. For December 25th, we look at the afternoon flood tide period. We'll have to choose between 1450 hours and 2031 hours. When we come to our tidal curve graph, we first need to write down the corresponding tidal heights in our time interval. And we have to write our height of tide value, which we've found at the beginning of the question. When we come to use the curve graph, we will lower a line from the desired tidal height value to the line we drew between the high water value and the low water value. From the intersection point caused by the lowered line, we will draw a line to the graph. But wait, we are missing a nuance. As you can see, we have two lines, spring tide, continuous line, and neap tide, dashed line, with values next to them. So which line do we use? It's very simple to find out. We take the differences of the mean ranges. If the difference value we find is above the differences of the high water and low water values, for this scenario, 11.0 minus 1.2 is 9.8 meters, we draw a line on the continuous line. If it is below, draw on the dashed line. If it is a value in between, we draw a line somewhere near to the closer value. Finally, we draw a line from the intersection point with the line we drew with the curve to our timeline. For the timetable, write the high water time in the space labeled 8W and find the time difference to the part we drew a line. And so we find at which time we have the desired tidal height. Thus, we find our estimated time of departure from St. Heiler, 25th December, 18th, 11 hours, Zulu time zone. For the Folly Inn port, we do the same procedure. What we need subtracted by what we have. 6.7 meters subtracted by 4.7 meters equal to 2.0 meters. That's our minimum required height of tide. For the height of tide maximum value, we calculate the data given to us in the question on this drawing. To find the air draft value, we subtract the draft value from the height above keel value. And for bridge height, we draw over the MHWS, mean high water spring value. For the MHWS value, we will look at the table with the properties of the port. The mean high water spring value of the standard port of Folly Inn port is 4.7 meters. The adjusting value for the mean high water spring of Folly Inn port is minus 0.6 meters. And as you can see at the bottom, it says that we can neglect seasonal changes. So we're not going to make any extra adjustment. Thus, we get our mean high water spring value of 4.1 meters. And if we do the math, we'll find the required height of tide is equal to 3.0 meters. After finding the ETD, we can move to the next port. As the question says, it takes 24 hours to reach the next port. So our estimated time of arrival at the port is December 26th, 18th, 11 hours. However, we do not know if we can enter the port at this time. So again, we will have to choose a suitable time interval and calculate at which time we can arrive at the port. As we mentioned, this port is a secondary port, so we'll have to use our tidal prediction form for our time and height, so let's fill in the blanks. For time and tide height corrections, for high water we use these red parts. For low water we use the blue parts. For the time corrections, let's put our high water and low water times, and let's see between which 2 hours they are. For high water, the 1306 hours is between 1200 and 1800 hours, and this is how we're going to relate these hours. If there is a plus 30-minute increase from minus 15 to plus 115 in 6 hours, which is 360 minutes, how many minutes of increase will it take to 1306, which is 66 minutes? If we calculate this, we will find 5.5, and we can round it to 6. So we add plus 6 to minus 15, we'll find our correction time. That's 0.0009 minutes. I will write this value up to save it. We will do the same relationship for low water. 1903 hours is between 1700 and 2300 hours. If there's a decrease of 20 minutes in 360 minutes, how many minutes of reduction for 1903 hours, which is 123 minutes? If we calculate, we will find minus 6.8. We can round it to minus 7. So if we add minus 7 to 0, we get 0.0007 minutes for our correction time of the low water. Let's go back to our table and write these values in their places. And as for tidal height corrections, first, let's place our tidal heights of our standard port, and let's see which side of the tidal height ranges they are on. Our height for high water is 4.3 meters. The difference between 4.7 meters and 3.8 meters is 0.9 meters. So we can make a correlation like this. If there is a 0.2 increase in a 0.9 meter decrease, how much increase is there in a 0.4 meter decrease? If we calculate, we will get 0.088, which can be rounded to 0.1. So if we add 0.1 to minus 0.6, we find our correction height minus 0.5. I will write this above. We will do the same thing for low water. Hang on a minute, 0.7 meters is not in between. This means that we will take whichever value is above or below it. In this scenario, 0.7 is below 0.8. That means we will use the correction value corresponding to 0.8. So our correction height for low water is plus 0.2 meters. Let's go back to the tidal prediction form and write down the values we've found. And for the seasonal change, we already found that it is negligible while calculating the height of tide. So I will write an empty set. When we do the calculations, we find 1257 hours and 3.8 meters for the high water. And for the low water, the time is 1856, and the height is 0.9 meters. And our tidal range is 2.9 meters. Now we can go to our tide curve graph. Let's put our values in the table, and if we look at our graph, it is an inverted graph, which means that the graph is based on low water. So we will write the low water time. But wait, you will see that the time we arrive at the port is already past the time when the tidal heights are appropriate for us. So we need to move on to the next period. So we're going to move into the flood tide. As you can see, 2156 is our estimated time of arrival. Thus, our estimated time of arrival is December 26th, 2156, Zulu time zone. Finally, it remained to find the set and drift values of the tidal currents. We will use the Charlie tidal diamond to find the values for St. Heiler Port. We use this table as follows. On the left side, there is the hours section. We put the high water time in its place and get the time difference between the time we are in the port. If we arrived at the port before the high water time, we move up in the table by the time difference. If we arrived after the high water time, we go down in the table by the time difference. In St. Heiler Port, we left at 1811. High water time was 2031 hrs. The time difference is 2 hours and 20 minutes. Since it is below 2.5 hours, we can round it up to 2 hours. Thus, we can get our values for Charlie Tidal Diamond from the before 2 hours section. As you can see, there are 3 numbers. It is very simple to understand which one is drift or set. The 3-digit numbers in bold is the set of the tidal current that indicates a direction, and the unit is degrees. The 2 fractional numbers in normal font indicate drift values. The one on the left side indicates the maximum drift, the drift at the spring tide. The value on the right side indicates the minimum drift, the drift at the neap tide. It is very simple to find out which tide time we are at. If you look at the tide period page for the days, there will be signs under some days. If there is a full moon or new moon, it is spring tide. If there is a first quarter moon or a third quarter moon, it is neap tide. As the result, we take our set value as 150 degrees and our drift as the average drift value since it is not at spring or neap tide. Therefore, tidal current's drift is 0.15 knots. As for the tidal stream table for Folly in port, since we have changed the tidal period, we need to use the new high water time. To find the correct high water time, we go back here and do the calculation as we did at the beginning and find the correct high water time. Now that we've found the correct time, we can continue. 0202 is our high water time. Our arrival time at the port is 21:56. We arrived at the port before the high water time, so we will go upwards on the table. The time difference is about 4 hours, so we will go up by 4 units. Since the question asked us to choose Bravo Tidal Diamond as the port of arrival, we draw our line there, and so we find our set, 120 degrees. And since we are not in a special tide time, we take the average value for the drift. So the drift is 0.15 knots again. And that was the solution of the question. Thank you for taking your time for watching my video.